O-Level Practical 2013. So when you see the word lime water, it means that it's likely to be a test for carbon dioxide gas. And if carbon dioxide gas is given off, there would be a white PPT. So this tells you that the substance, which in this case is salt X, would likely contain carbonate ion. Okay, and then when they talk about heating the boiling tube gently and then more strongly until no further changes are seen, this is decomposition. So we need to think that there would be likely a change in state or a color change, and there may be gas produced. So if gas is produced here, we need to pass this gas through lime water, even though they did not state it for us, but the instruction says to test for any gas involved, so we need to do that. And if you see any condensation forming, it's perhaps because it's a hydrated salt, so there is the water evaporating and then condensing at the cooler part of the boiling tube. So when you do this, remember to be patient. So this is where we will prepare our lime water. And it says 3 cm cube, so we would put 3 pumps of lime water into the test tube, and we also need our delivery tube. So once we place 3 pumps of lime water in the test tube, we put the delivery tube into this test tube such that the delivery tube will be able to pass the gas through. So now, because we are going to heat the boiling tube gently, we need to light up the Bunsen burner first. So we need to have an open air hole. So you turn the collar to open the air hole. So this is our salt X. It says boiling tube. So this is the bigger tube. That's why it's called the boiling tube. So we have to heat it gently, then strongly, until no further change. So here we put the delivery tube into the boiling tube once we see that there's some gas involved. This is a green solid. When we heat it gently, we heat it nearer to the top of the Bunsen burner flame. Then when we heat strongly, we bring it down nearer. So every time we are testing for any of the gas involved, we need to be patient and we need to wait. Usually this will take a few minutes. So after a few minutes, you see that the green solid will start to become black, and you can see that we're heating the solid strongly now. And you can see that the gas is evolving, and the gas evolved forms a white PPT in lime water. So once the white PPT is formed in lime water, we can stop, as this shows that carbon dioxide gas was evolved. Okay, and if you look at the solid, it has turned from green to black. For the next part, this is called a flame test. So for flame test, there are a few colors, and from the color of the flame, you can tell which ion is present. So we need to soak the end of the wooden spleen. So we put a splint in to make the splint wet. And once the splint is wet, cover as much of the splint with the salt X. Okay, next we make sure our Bunsen burner has a blue flame, so it's easier to see the change in the color. So this is our blue flame. And once you put this spleen in, you can see a lightish green at the top. Okay, but it goes away pretty fast, which is why you think it's orange and yellow. So we'll do it one more time, and you can see that greenish color at the top. Okay, so this is a green flame that is being seen. So here when we add acid Y, when we add acid, it's always either to dissolve, or there will be a reaction of acid with metal, or in this case metal carbonate, or it could also be base. It could also be a test for anion, which is a carbonate ion. So this is what we need to keep in mind. Okay, and then as we continue, when it says gently heat and stir until no further change is seen, means that there is more than one observation that can be made. Okay, so this is how the experiment needs to be carried out. So we have our black solid from the cooled void test tube. We add acid Y, and from here you can see if there is any change. So we stir the mixture, and if you tilt this boiling tube slightly, you may see that there is a light blue solution with the black solid being left behind. Okay, but if you can't see anything, then you will proceed on to transfer them to a beaker. So in this case, you don't see much of a change, so you could also write no visible change. And for this part, it's only one mark. So therefore, what would be the observation that you see? So now that we are heating, and at the same time stirring the mixture, we need to do this until no further change is seen. So again, it takes a few minutes, and we need to remember that there could be more than one observation that could be made. In this case, there is no gas being evolved, so we do not need to test for any gas. So unless you are patient and you stir and you wait, you won't be able to see what happens. So after some time, you can see that the black solid dissolves in acid Y or reacts with acid Y to form a blue solution. So as the beaker is still hot, we'll remove it so that you can see the blue solution clearly. For part D, we need to add magnesium ribbon. So when you see magnesium ribbon, you should think of either a displacement reaction, where a more reactive metal displaces a less reactive metal from its solution, therefore getting some form of a coating, or reaction of acid with metal, and in this case hydrogen gas may be produced, so we need to test with a lighted spleen. And this observation needs to be for a few minutes so that you can see all the changes. And this part has 3 marks. So first of all, we'll prepare the solution Z. So 2 cubic centimeters means about 2 palms. Then we need to add the 3 pieces of magnesium ribbon. And before we do so, we make sure that our lighted spleen is ready. So once we put in the magnesium ribbon, you should see some effervescence. Then we test with a lighted spleen so it extinguishes with a pop sound. After a few minutes, you will see that this blue solution becomes lighter and finally would turn colorless. If you are not sure about the color, you can compare it to the blue solution in the beaker and see what happened to the color of the solution. Okay, so we put it near so that you can compare. And the other thing you can do is you can also touch the test tube lightly and see if it's an exothermic or endothermic reaction. So if this test tube feels warm, it is an exothermic reaction. And if it feels cold, it is an endothermic reaction. So from this part, we can also tell about the reaction regarding its energy changes. So we have seen a few things so far. We have seen that there is effervescence, that the lighted spleen extinguishes with a pop sound, and that the test tube feels warm. So from the fact that the lighted spleen extinguished with a pop sound, it means that hydrogen gas was produced. Okay, and now if we are unsure of what was that reddish brown solid formed, once the reaction is over, you could go to the sink and pour the magnesium ribbon out. If it does not come out, you can use the glass rod to gently bring the magnesium ribbon out with the reddish brown solid, and with a closer look, you can see that the reddish brown solid is formed over the magnesium ribbon. So it's not that the magnesium ribbon turned reddish brown, it is not. Instead, there is a red brown solid that is formed over the grey magnesium ribbon. And this red brown solid is the metal that was displaced. Okay, for part E, this is the test for an ion, which is sulfate ion. And if sulfate ion is present, this means that likely you will see a white precipitate. So here we are testing what the solution set contain. So this is a test for sulfate ion, and you should expect to see white PPT if sulfate ion is present. Okay, how did we get solution Z? We get solution Z by reacting acid Y with our black solid. So our black solid is copper 2 oxide. So if copper 2 oxide reacts with sulfuric acid, there you get copper 2 sulfate, which is your blue solution. So what we can see right now is we can see that there is a white PPT. Okay, if you are unclear of the color, you can let it settle in the test tube rack, and you can see that the white PPT will settle right at the bottom of the test tube. So this is white PPT and not like blue PPT. Okay, this is a sulfate ion test. Okay, for part F, this is a cation test, and because it says until no further change is seen, it means you have to add aqueous ammonia in excess. So for the start, we will add aqueous ammonia a few drops, then followed by adding till 1/3 of the test tube. Okay, so here we are preparing our solution Z once more, 1 pump of solution Z. So now we add in our aqueous ammonia. So if earlier on your flame test was a green flame and you suspect that there is copper 2 ion in salt X, so since solution Z is likely to be copper 2 sulfate. And if copper 2 ion is present, you should see a blue PPT. And this blue PPT will be soluble in excess to give a dark blue solution. So let's add a little more to see what happens. You have to add until there's no further change. Okay, so here you can see the blue PPT clearly now. And because we want to add in excess, we have to pour away some of this PPT. So after pouring some of this PPT, we will then add more aqueous ammonia until 1/3 of the test tube or 3 times of the starting amount. So if you follow the chemistry practical notes given to you during your exam, this is exactly what you write. Light blue PPT formed, soluble in excess, giving a dark blue solution. You can see it's a solution because when you pass light through it, it's clear. Okay, now for the last few parts. So when we add sodium chloride, this is an adding of a soluble salt. So it's either that there will be a color change or there will be some form of precipitation if an insoluble salt is formed. Okay, and then after that, we will need to add water. So when you're adding water, you think of either there could be a color change or it could be dilution. Okay, so this adding of sodium chloride is common. So let's take a look and see what happens. So first again, we prepare solution Z. And then next we'll add 1 spatula load of solid sodium chloride. So the blue solution turns green. If you are not sure, you could compare it to the previous blue solution and you can see that there is a change in color, which is green. Next, you are then to add deionized water until it's half full and shake. And once you do so, you notice that the green solution turns blue again. So this is our conclusion. Acid Y is sulfuric acid. Because sulfuric acid gives us that sulfate ion, therefore our evidence, we say that in that test, in that particular part, we saw the white PPT when acidified barium nitrate is added. Okay, and for the other two, these are the two other conclusions. And remember the evidences, you need the part, you need the observation, and you need the description. So what you see and what you did and the part.